This is the implicit question number 2, promise from last time. Show that there are no points on the graph of x squared minus 3xy plus y squared equals 1 with a horizontal tangent line. So if you'd like to solve this on your own, please pause the video here. So the idea of a horizontal tangent line is, as we've discussed, that means that the derivative, or y prime, has to equal 0. That's what a horizontal tangent line indicates. So the first thing we need to do is we need to find y prime. Because this is not a equation where x is a function of y, it doesn't want to write that in, I have to go ahead and use implicit differentiation. So we're going to do that now. So to find the derivative of the first piece, x squared, that's easy, that's 2x. Oop. 2x. I don't need to put in y because it's not there. I'm not quite sure what that little piece is right here, so I'm going to cross that off in case it's confusing you. I don't know why that's there. Maybe it just was errant when I made that underline. So looking at that, now I'm going to go ahead and find the derivative of that. Now to use that, I'm going to need to use product rule. Notice there is a minus, so this is tricky because I'm going to go ahead and put the minus there, and then I'm going to put the 3 there as well, because I like to move those constants out, and I'm going to find the derivative of x. The derivative of x is 1, and then I'm going to put y. Then I'm going to write plus, and then I'm going to put x, and the derivative of y is 1, but then I need that y prime as well, because I found the derivative of y. And then last but not least, I have the y squared, so that's going to be plus 2y. I shouldn't say it's last, but plus 2y, y prime. And then truly last, I have to remember to find the derivative of this 1, and that's going to be 0. So now I'm going to write this out by distributing it out. It's going to be 2x minus 3y minus 3xy prime plus 2y y prime equals 0. I'm going to move everything that's not y prime over, factor out the y prime. Now I'm going to do this a little differently because I'm going to call it 2y y prime. I like to put my positives in front. It makes it easier when I factor things out, just for my brain. So y prime, and then I'm going to move this over, so it's going to be 3y minus 2x. And then I am going to divide out what's going to be left after I factor. So 2y minus 3x. So it's going to be y prime equals 3y minus 2x over 2y minus 3x. Okay? Now I'm trying to show that there are no points on the graph of this with a horizontal tangent line. Alright, I kind of zoomed in here a bit so it would be easier to see. So I'm trying to show that there's no points for this ratio with a 0 tangent line, which I'm trying to show that there's no points, that this could be 0. So for that to be the case, I would need 3y minus 2x to equal 0, which means 3y would have to equal 2x. And the only time that that would be the case, logically speaking, is if y and x equals 0. But that's not a really good way to show it. So instead we say, okay, well let's go ahead and let's set my y equal to 2/3 x. We'll do like a really good solid proof. If that's the case, and I plug this into my original equation, I'm going to get x squared minus 3 times x times 2/3 x, and then I'm going to go plus 2/3 x squared, and that's going to equal 1. And if I do some simplification, that 3 is going to divide out with that. I'm going to end up with 2x squared, so x squared minus 2x squared is going to be negative x squared. And then I'm going to have plus, I'm going to have 4/9 x squared, and that equals to 1. So negative 1 plus 4/9 x squared would be negative 5/9 x squared equals 1, which would be x squared equals negative 9/5. Now, if I square root both sides, because of that negative right here, I'm going to end up with a no real solution. So you can kind of logic right here that that can't work because this can't work unless both x and y are 0. And x and y can't be 0 because if x and y are both 0, then it would make this piece down here in the denominator a big, big problem. So logically that makes sense. But then we did this empirical proof right here. Oh, didn't move through the way I thought. Right here. This piece is the kind of that logical part. And that logical part says, well, if I sub in y equals 2/3 x, and I put the 2/3 x there and the 2/3 x there for y, and boil it all down, I get to this equation right here where x squared equals a negative number, and that provides us with no real solution. So that's the discussion as to why the tangent line can't be horizontal. This is kind of a good theory, but it's not proven. And then this over here is where we actually do the work to prove it and show that it can't be true.